Okay, let's go on to the maths now. Now look, you have a lot of work to do. You have to finish your essay, and you have to do your physics homework, and your maths homework, and go to school. Right?
It's the hard one.
It's the hardest of them all, yeah. Okay. Can we have a look at the maths now? So, let's get started. We all know what this equals. What does this equal? Oh, come on, don't be too tired.
X squared.
X squared. Okay. And we all know what this equals. What does that equal?
Cosine x minus cosine x plus c.
But this, guess what, is not x squared cos x plus c. It's not that simple. We can't do this. Okay, we need a special rule now. We need a rule when we're multiplying and we want to integrate. Okay, so what is the rule? Rule is not so difficult. Here's the rule. It's called the by parts formula. And when you want to integrate f g derivative, that's equal to fg minus integrate f derivative g dx. This is the by parts formula. Now I'll explain how to use it in a moment, but if you can just write that down, that's the formula we need for today. Yeah?
Why is this over? Why not just plus them together?
I'll explain now. I'll give you the proof, okay? Here's the proof. So, if you differentiate this derivative and antiderivative, they cancel. So you're left with this. Okay? If you differentiate this, what will you get? This piece. You'll get f derivative g plus f g derivative. Okay? And if you differentiate this, what do you get?
F derivative g.
Yes, minus f derivative g. Now, can you see that and that cancels, and you're left with fg derivative equals... Oh, sorry, do you need to move, Gav? Or will I move? Can you see okay? Yeah? So, you see the proof is very simple. So this equals this, so it's true. So that's why it has to be a minus here. Okay. Now let me show you how the rule works. Can I scroll down? Okay, so here's our first example. We want to integrate x cos x dx. Okay. What you do, you make a table, and you call this guy f, and this guy g derivative. Okay, so you have f equals f derivative equals g equals g derivative equals. Right, so we know what f is. What's f?
X.
It's x. And we know what g derivative is. What is it?
Cos x.
Cos x. We said g derivative is cos x.
You wrote g derivative two times.
Oh, for goodness sake. Sorry. So sleepy. G and g derivative. Okay, so f is x and g derivative is
Cos x.
cos x. What's f derivative? Well, it's 1
So, okay.
because f is x.
Mm.
Now be careful. If g derivative is cos x,
Sin x.
what's g?
Sin x.
It's sin x. Okay. If I use my rule, this should equal f g minus integrate f derivative g. Now, do you see what's happened? Look, you've taken something which is hard,
To solve.
and now you've changed it into something which is easy. Because this is just going to be x sine x. This becomes minus cos x, and the minus there makes it
Mm.
plus cos x plus c. So this rule, it takes a hard problem
Just.
and changes it into an easy one. This is the idea. Okay, I'll do more examples. That's an easy example. You can write that down. Yeah? Yeah? Okay. We'll do another example?
Since x in x minus 1 in x dx,
Mhm.
the answer that is x in x plus the
Mhm.
1 up won't bring it down.
Which one?
The 1 before.
I don't have
It's
to.
not,
It's
okay.
okay. Yeah. Can I scroll down? Khalifa, can I scroll down?
Yes.
Okay, let's have a look at another one now. So let's say we have integrate x ex dx. Okay. So what's f?
1.
X. F derivative?
1.
1. G derivative? Ex. And g? Ex. So this should equal fg minus integrate f derivative g. Yeah. And that's equal to x ex minus ex plus c. Okay. I'm going to give you one to try now. I'll make it a little harder. Okay? I want you to integrate x squared ex. Alright, try that. Get an answer? So who's right or who's wrong? So this question is a little bit harder because
X squared.
yeah, you have to use the rule twice. So first you have x squared, and then here 2x, and here this is ex. What's wrong, Gav? Are you watching? Watch. Just watch. So that's fg minus integrate fg. Like that. F derivative g. Yeah?
Yes.
But we have, well, let me just take the 2 out. Okay? But now we have to use the rule again. So you have x1 ex. So this becomes x squared ex minus 2 bracket, and then we repeat fg minus f derivative g. Like that. So that becomes x squared ex minus 2x ex plus 2ex plus c. See, because you have to use it twice.
Minus C.
It doesn't matter. Doesn't matter. So you could probably guess if I asked you to do this one, how many times would you need the rule?
3.
You would need it 3 times.
Yeah.
You see? Yeah? Okay. Now, is this the same as this? Sine x times x. Are they the same or different? No, they're the same. It doesn't matter if you swap them. But of course, you realise, of course, the difference. The difference is here you call this f and this g derivative, and here you call this f and that's g derivative. Now the real question is, you'll get the same answer, but which is easier to do? And the first one is easier. This one is easier. Do you know why?
Because we can cancel the x.
That's it, you can cancel the x, yeah. So, if you have to choose, you should choose to write it like this, not like this. How can you remember? There's a way to remember. You can use this word, L-I-A-T-E. So the L means log. So if you have a log, you should put the log first. Okay? So for example, log x, sine x is good, but sine x, log x, that's bad. You should put the log first. Okay? The I stands for inverse. Sine inverse, cos inverse, tan inverse. Okay? The A stands for algebra. That's things like this, x power n. The T stands for trigonometry. That's like sine or cos. And the E stands for E. So you should try to write it in this order. This is the best order. You should write this word down. It's a helpful trick.
What's the meaning?
Of what, the word?
Yeah.
It's just a made-up word. It's not a real word.
Okay.
It's like latte. Liat.
Yeah.
It means your maths and physics teacher is very smart. That's what it means. Have you seen this before? Or is this new? It's new. Okay. Right, do you want to try a hard one? Hard one.
Come on.
That was medium. Now time for hard.
Let's go.
Yeah, okay, good. Right. Try this one. Good luck.
Sine, cosine, sine, cosine, sine, cosine.
Keep cycling. So the question now, Gao, is how to break the cycle. Shall we do it? Yes? Yes, I'll do it.
Yes.
Yeah, no, they're confused. Summer, let's do it. Come on, look. Look. So, step one, first step,
F.
change this into integrate cos x ex dx. Okay, that's step one. Now, if you use this here, f
Cos X.
minus sine x, yeah, ex, ex. Yeah. So this is equal
So
to,
the answer is
EX.
sine x ex plus cosine x ex.
Yes.
I think so.
Plus C.
Yeah.
So
Ex
cos
cos x.
plus sine.
Hang on. Yeah, plus because two minuses. Yeah. Plus ex sine x
Plus dx.
dx.
Okay.
Yeah.
Then go down. Ex cos x
Cos x.
plus cos sine x plus
Yeah. Ex. You should swap them.
ex plus. Okay.
Yeah. Right, now if we use the rule again, what's that? Sine x,
Sine x.
cos x, ex. So this will equal ex cos x plus ex sine x minus integrate cos x ex. Ex cos x.
Dx
Yeah, that's it.
Yeah.
That's it. So this is ex cos x,
plus cos x.
ex sine x. Go.
Minus
Go.
x.
You are asking how do you break the cycle because you're back here.
Yeah.
Now you need to remember that this is equal to this.
Yeah.
You got here, didn't you?
Cancel.
Well, not cancel, but
That means.
you can bring this over here,
Yeah.
and you have two of them.
Yeah.
You forgot your two.
Yeah, it's two, but oh.
Answers 1 over 2.
Yeah. So you divide by 2, and then don't forget your plus c. Yeah. I think you just forgot the 2.
Yeah.
Okay. Nearly got it. I can do it. We can do another one. Ben, do you need to write this down, or it's okay? Okay. Yeah? Yeah? Can I scroll down, Ben? Go? Yeah? Okay. Give you another one. Try this now. Integrate log x dx. Hang on. Did we do the question on page 100, the page before that? Did we do this lesson?
Yes.
We did, yeah. Oh yeah, we did. Tan inverse. Yeah. Alright, try this. Is not 1 over x, because the derivative of log x is 1 over x. Any ideas? Ah, no, you don't. English.
It's not the one word.
Definitely not. Huh? Oh. Ready? Let's look. Look. So, you change this into log x times 1 dx. F derivative, g derivative, g. Yeah. X log x minus integrate f derivative g. Yeah? Dx. Now what happens here? They cancel.
Yeah. 1
And what do you get? X log x minus x plus c. Don't like?
What?
It's great.
Yeah.
I like it.
Sorry, to show me the, if you change the order, how can they not say that?
You can't, it's too hard.
No, not this one. If it was before
Like what?
x and cosine x, is it say answer?
We can try, just before I do that, just to finish, sometimes they put limits here, okay? So you have to be careful because the limits go on both these parts, alright? It goes on the whole thing. Of course you don't need to see anymore. Yeah? So if you put in 2, you get 2 log 2 minus 2, and if you put in 1, you get minus minus 1. So that's answer is 2 log 2 minus 1.
And
Yeah.
1 is 0.
Yeah. Yeah. So that's equal to log 4 minus 1. Okay? Now, Gail, what was your question? You want me to try to integrate?
X cosine x. No, cosine x x.
Yeah, it's very hard, is it? I'll try, but I might not be able to do it. Cos x x dx. Now, this is wrong. This is hard. Because it should be the other way. Let's see what happens. Okay. F derivative, g, you see, what's g, this is g derivative, what's g? A half x squared. Oh, I already don't like it. So this is f g, yeah, minus sine x times, but this is f derivative times a half x squared, isn't it?
No, times
Yes,
x.
x. Yes, x.
Times
Hang on,
x.
hang on, hang on. Fg,
It's half x.
it's a half x squared, yeah. Because this is f derivative g derivative, and it's g minus integrate f derivative g. It's this. Two minuses. Yeah. Okay. So that's equal to x squared over 2 cos x plus, and then what we have to do is it again. So f cos x squared over 2, this x cubed over 6.
So it's a circle?
It's worse, yeah, it's worse than that. So this is f g, yeah, minus integrate f derivative and then x cubed over 6.
So it's never finished?
It's not finishing. So what will happen is you'll get x squared over 2 cos x plus x cubed over 6 sin x plus x 4 over 24 cos x plus, and I'll just keep continuing.
But how can you know it's the same?
Well, you can see what's happening. So each time you integrate your sine and cos, they swap. So if I was to do it the next time here, okay, you would have cos x minus sine x, x cubed over 6, and this would be x 4 over 24. So when you do cos x times this, oh sorry, that's it's a minus, isn't it? So that should be a minus then. And then it's cos x. And then it again and again and again and again. So it keeps increasing.
No, but my question is how can you know is this one is the same as the easy one answer? You said before they will say.
Oh, that's hard to prove.
So that's why I'm checking.
Yeah, yeah. Like for example, you will study this at university. So for example, believe it or not, this is the same as this. I mean, they look different, but they're the same. You can check it out. So for example, if you say x is 1, then e power 1 equals 1 plus 1 plus 1 over 2 plus 1 over 6, etc., etc. Now, of course, we can't go to infinity. So roughly, this is 2.718, roughly. And if you add these together on your calculator, what do you get? 2.5 plus that. So 2.67. It's roughly right. Yeah, roughly. Have you seen this before? No. Here's another one for you, Go. You can say sine x is equal to x minus x cubed over 3 plus x5 over something I don't remember, like 120 or something. I can't remember. You can write something which is small into something which continues. And you did this in semester 1, do you remember? Remember?
Oh, yeah.
What's that?
Go. You know this. You do. Yeah. This is the same as this.
I read this formula.
You did.
Oh, I know that's formula, but I don't know what's that equal.
Without 1 plus r squared plus r squared.
You know this.
Yeah, I know this. I only know this.
But you also know this. You do. No, you do. Look. look, 1 plus r squared plus r cubed, dot, 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 dot. What's the a? 1. What's the or? Or. Okay? So this is equal to s infinity, which is equal to a over 1 minus r, which is equal to 1 over 1 minus r. So, you can say 1 over 1 minus x equals 1 plus x squared plus x cubed.
Yes.
That's the question. They give
Yeah.
us an example as
Yeah,
that's the question.
You see? You got it. Okay, good. Good. Right. So, I'll let you try these for a few minutes, okay? Oh, well, we don't have to... don't do it, but just tell me how to do it. How might we do this one? What could we do here?
Put the x in form of sign. Oh, no.
No.
What's this?
Do the table.
Yeah, but before I can do that, 1 minus cos squared? No.
Will you change that to another form?
Yeah? What form? Oh, come on. Wake up.
Sin x plus sin x.
Thank you, Ben. You're awake. Good man. And then this is f and this is g derivative. Yeah, good. Okay. Right. I'll let you try these for a few minutes, okay? What have we got? We've got 10 minutes left. Try these for 10 minutes.